Welcome all. My name is Suresh, lecturer in ECE from Government Polytechnic Bellampalli. Today I am going to teach the subject microcontroller programming, which is in the fourth semester of C18 curriculum of State Board of Technical Education and Training, Telangana, and the subject code is EI 402. It is in the Electronics and Instrumentation branch subject. Today's topic is architecture of microcontroller, that is 8051 microcontroller. This is the syllabus of chapter 1, that is architecture of microcontroller 8051. In that we have certain objectives. Under this chapter one must learn all these topics. That is, if you see, first subtopic is draw the block diagram of a microcomputer microcomputer and explain the function of each block. Second subtopic is compare microprocessors and microcontrollers. Afterwards, list the applications of microcontrollers. State the Intel microcontroller family chips and list the features of various Intel microcontroller family chips. Compare the various Intel microcontroller families. State the features of Intel 8051 microcontroller. Explain multiplexing and demultiplexing in 8051. Draw the functional block diagram of 8051 microcontroller. Explain the function of each block. Each block, what block? In the 1.9 topic, that is draw the functional block diagram of 8051 microcontroller, and the 1.10 subtopic, that is explain the function of each block. In this functional block diagram, the above 1.9 whatever the subtopic is, in that we will draw the functional block diagram of 8051 microcontroller and we will explain each function of each block. And 1.11, that is the draw the register structure of 8051 and explain the register structure. Next, explain the function of various special function registers, SFRs. Simply they are called as SFRs. And then draw the pin diagram of 8051 microcontroller and specify the purpose of each pin. Explain internal memory organization in 8051. Explain interrupts in 8051. So these are the objectives under this chapter, that is architecture of microcontroller 8051. From the name of this chapter itself, we will learn only the architecture of microcontroller, that is specifically it is the 8051, only the 8051 microcontrollers architecture we will learn, and we will not directly jump into these microcontroller topics, because in the first subtopics we will know about what do you mean by a computer, microcomputer, and function of each block of this microcomputer, and the difference between microprocessors and microcontrollers. Then we will move on to the available in the real world available Intel microcontroller families chips, and what are the when they have been manufactured and invented, what is the difference between the subsequent families of these microcontrollers, and what is the features of this particular Intel company's 8051 microcontrollers, and concepts of some important topics in this 8051, that is multiplexing and demultiplexing. Then afterwards we will move on to the specific microcontroller, that is 8051. So after completion of half of the topics in this first chapter, then we will go to the specific 8051. So first see the topic. Draw the block diagram of a microcomputer and explain the function of each block. So this is a simple block diagram of a microcomputer. And that figure 1.1a is a block diagram of a microcomputer, and 1.1b is a block diagram of microcomputer with additional what do you see the difference here? Same input device, output device, and there is a MPU, that is microprocessor unit, and there is a memory unit, simplified memory unit. There in the first block diagram, you will see the different blocks in this memory unit, that is separate RAM, separate ROM, and auxiliary memories. But in the below diagram, we represent the whole RAM, ROM, and auxiliary memory as a single unit, that is a memory unit. So you can draw any of the block diagrams in the exam, but now you must draw two block diagrams. Please everyone draw these block diagrams. I can wait 2 minutes. Please draw it. I hope everyone has completed their block diagram. Now observe this block diagram. In the first block diagram, that is figure 1.1a, we have input block which is connected to this MPU, microprocessor unit, and there is an output block which is connected to this MPU block. But observe the arrow directions. The input blocks will be unidirectional, that means they will be connected to the microprocessor, and the input blocks will give the inputs to this MPU. So this processor, simply you can call it as processor, and outputs receive the commands from the processor. Output block receives the command from processor, and above we have the memory unit. Simply the memory unit, that is it consists of ROM, read-only memory, RAM, random access memory, and auxiliary memory. And this combined memory unit is connected to this processor, and it is a bidirectional. See the arrow direction. So it is a bidirectional. That means memory unit will store the information, and it also retrieves the information from the processor. It also gives the information to the processor. So it is a bidirectional bus. It will have a bidirectional bus to communicate with the processor. And the same figure 1.1a is represented in figure 1.1b as the block diagram of microcomputer with additional memory unit. We have input device, the bus is connected to microprocessor, and the output device which is connected to the microprocessor, and they are unidirectional. The memory unit we have bidirectional bus which is connected to microprocessor. So this is the explanation. Actually, this is the connections of this block diagram. The explanation is also simple, and most of you have already learned about this computers and their architectures, simple architectures in the IT lab, information technology lab, or CF lab, computer fundamentals lab, whatever it is called, in the first semester or second semester of this diploma course. Now see the theory part, that is a digital computer in which one microprocessor has been provided to act as a CPU is called microcomputer. In the topic we have a microcomputer, right? So a digital computer in which one microprocessor has been provided to act as a CPU is called microcomputer. It is the smallest and least expensive general purpose computer. It is a general purpose computer, not a specific application specific computer. It is a general purpose computer. Figure shows the block diagram of microcomputer. It mainly consists of four sections, namely microprocessor, input device, output device, and memory. First, see the MPU, that is microprocessor unit. The CPU of a microcomputer is a microprocessor. See, you may get confused with these words microcomputer, microprocessor, microcontroller. Okay, so repeat those words and read them again and again within these 2 3 days. So you will be um, habituated with these words and we will know the difference between these words. The CPU of a microcomputer is a processor. The microprocessor. The major components of a microprocessor are ALU, that is arithmetic logic unit, register array, and timing and control unit. Right? The major components of a microprocessor are ALU, register array, and timing and control unit. The heart of a microcomputer is MP, microprocessor unit. And the microprocessor unit is a VLSI device. VLSI means very large scale integrated circuit. Very large scale integrated circuits. It means on a chip of size 1 by 1 centimeter by 1 centimeter area, there will be more than 1 lakh transistors will be manufactured. That means they will be implanted on this small area. That much advancement of technology has happened from the invention of basic computer in the 1980s or 1960s. With the evolution of transistor technology and by following the Moore's law, the transistor technology and the semiconductor technology which will be used to manufacture these processors in the labs has evolved in these recent decades with such a great efficacy. And presently we are under ULSA, that is ultra large scale, or more than that also happened, but particularly here it is a VLSI device, that is very large scale integrated circuits. We have basically small scale integrated circuits, that is then 10 logic devices or less than 10 transistors are manufactured on a small area of 1 centimeter by 1 centimeter size, and then medium size which is less than 100, and then large size less than 1000, and very large, and then again it is moving into VLSI, that is greater than 1 lakh minimum of number of transistors are manufactured on the small area. It is a general purpose processing unit built into a single integrated circuit. Single IC. We are talking about the processor, right? The microprocessor. If you can remember from the first sem or second sem computer a small square shape device, electronic device. If you can see, um, that is on that you will see a number of transistors and number of iron things are implemented on that particular area. It is literally small, right? In that, if you consider around 1 centimeter by 1 centimeter size, also there will be more than 1 lakh transistors are manufactured on that, implemented on that particular area. It is a decision making unit which decides the task to be performed by the system. The processor is the main unit. It is the decision making unit. It is the processor. It will decide what will happen, where to it store the result, or what we have to give to the input, what we have to take from the input, and what we have to give to the output. And so this is the main thing. This is like the heart or brain. You can consider as a brain. You can remember it as a memory, but it's not the only the memory, right? It will function along with the processing also. It may be 8-bit or 16-bit or 32-bit processor, depending on the size of the bus that is connected, and that can be connected to this processor, and the number of registers, size of the registers available in this processors. It is classified into 8-bit, 16-bit or 32-bit processor, right? 8-bit means it is a 1 byte. So if the registers are of main registers are of 8-bit size, then it is called a 8-bit processor. Generally, the main registers are accumulator register, A register, and we have different types of registers also there in the processors. As we are going into this chapter, you can understand what do you mean by the important registers or accumulator register, and why it is called a 8-bit or 16-bit or 32-bit processors. The MPU, microprocessor unit, executes instructions of the program and process data. Right? This is the main thing, because this will execute the instructions, whatever the instructions or whatever the software you may call it as a coding. It's code language. Generally, in the digital format, if you write, the processor will process this information, and that means it will execute the information. What we have written in this code language, the machine will understand, and the machine will execute the instruction. If there is no errors, no typing errors or no logical errors are there, then the processor will execute that instruction and the program and the process the data. Processing means anything that we tell the uh, processor or computer to do, right? That is the processing of the data. It is responsible for performing all arithmetic operations and making the logical decisions initiated by the computer's program, right? It is responsible for performing all arithmetic operations. What are the arithmetic operations? Generally, addition, subtraction, multiplication, division, and uh, again mathematical expressions like integration and differentiation, and making the logical decision, that is yes or no conditions and loop conditions, right? We have to test that condition if it is okay, if it is good, and if it is getting the result of what we have expected, then process this statement. If it is not getting the output what we have expected, then it should stop there. So such type of decision, that is logical decisions, also will be processed by this uh, MPU unit, which is initiated by the computer's program. So this is all the software side, software coding thing we will write in the coming lectures. So all those data will be processed by this MPU unit, microprocessor unit. And next is the memory unit, right? The memory unit is to use it to store data, address, or instructions in hexadecimal form. Hexadecimal forms, in the third semester of diploma, you have studied about the digital electronics, right? In that subject, first chapter, we will have different forms of data, that is binary data, decimal data, octal data, and hexadecimal data. Hexadecimal form of data. Hexadecimal, that is 16 different um, numbers or signs will be there from 0 to 15. That will 0 to 9 we have, and then afterwards 10 is represented as A and B, C, D, E, F. Right? In that format we will have the uh, data, or address, whatever we have. So it will be represented in this hexadecimal form. And what is the thing that is stored in memory that is used to store the data? Whatever the values we enter, or whatever the values it take to process, to do that particular instruction and to do the particular operation. And address is nothing but the um, place where that data or operations are stored, right? And instructions also we will write in the core language, and that instructions also will be stored in this memory. It is similar to the English language, but with some not exactly the same literal English words. It is a mnemonic language. The memory unit is subdivided into two parts as primary and secondary memory or auxiliary memory. The primary memory is also called as semiconductor memory. The primary memory is again divided into number of subunits in which RAM and ROM are important. So RAM and ROM are the only not the only two things that is available in this primary memory, but we have all the other memories also, but these are the most important things. The RAM is used to store the temporary data, where ROM is used to store permanent data. Permanent means it should not be volatile. That means when the power is off, when the device is switched off, the data should not be get erased. If it is erased, then it is a volatile data, and that is stored in RAM. If it is not erased while the power is off, then it is non-volatile, and it will be there though it is the power is off. Then it will be stored in the ROM, read-only memory. The secondary or auxiliary memory is a magnetic memory, that is external memory. We connected to this device. It is used to store large amount of data. Examples of secondary memory is hard disk. Everybody has heard about this hard disk or USB device or CD-ROMs or DVD RAMs. Now the micro SD cards, right? These are all the secondary or auxiliary memories. And input device. Next is input device. The computer receives the data and instructions to input devices. An input device converts the instructions, input data, and signals into proper binary form suitable for a digital computer. So this is what exactly the input device will do. It will convert the instructions, input data, and signals into proper binary form. Keyboard and simple switches are used as input device. These are the examples: keyboard and simple switches. Output device, the computer sends the processed data, that is the results, to the output devices. An output device may store, print, display, or send electrical signals to control certain equipment. The examples of output devices are LEDs, CRTs, digital to analog converters, video monitors, and printers, etc. So these are all the input and output devices examples, and we have seen about the block diagram of basic microcomputer, and we have seen different blocks and explanation of what each block in this topic. Now compare the microprocessor and microcontrollers. Microprocessor contains ALU and control unit. Control unit, in that we have clock and timings, and different registers and interrupt circuits will be available in microprocessor. In case of microcontroller, we have microcontroller contains microprocessor, comma memory, and I/O ports, peripheral devices such as analog to digital converter, timers, and counter. So microcontroller is generally more efficient than microprocessor because it will have the microcomputer. Along with that, we have Other usable external device, that is memory, IO ports, and peripheral device, and analog to digital converters also will be there. And in case of microprocessor, the second point, microprocessor must have many additional parts to function as a computer. So it requires external other things. Other parts also required to function as a computer. It is just a processor. It needs other parts to function as a full dedicated microcomputer. A microcontroller can function as a computer with the addition of no external parts. So it is itself is a simplified version of a microcomputer, that is a microcontroller. So it is the advanced version of this microprocessor, generally referred to as microcontroller. It does not need any external sources or things to function. Microprocessor based systems require more hardware. Hardware is also required, right? And microcontroller based systems require less hardware and reducing PCB size and increasing the reliability. And fourth one, microprocessor based system is more flexible in design point of view because it does only the processing area and remaining other things, that is the memory or IO device, and they need to be integrated with this microprocessor. Okay, so there is a possibility of separate design will be available for each and every part. But in case of microcontroller, it is less flexible because we need to consider all the timing considerations, power dissipation considerations. So all these conditions has to be met in order to design a full-fledged microcontroller. So we have to compromise in some of the areas in case of microcontrollers, but that is not the problem with the microprocessor. The fifth point is it has single memory map for data and coding, and it has, that is in case of microcontroller, it has separate memory map for data and code. That is in case of microprocessor, we have a single memory for both data and coding. That is for the instruction and for the data we supply or whatever it take, both will have the same memory. Same memory, in the same memory itself, these both data and code will be stored. But in case of microcontroller, we have separate memory for this data and code. So it is very useful, and it, because of this separate memory map, the speed of processing will be increased compared to microprocessor. Sixth point is very few pins are programmable. In case of microprocessor, very few pins. In a microprocessor and microcontroller, we have, when we have decided these ICs, we'll have number of pins. Then, depending on whether they are programmable or not, we will have different options, different multiplexing signals. One single pin can function more than two processor, more than two functions also it can do. That is, if it is programmable, we can change from our side, that is user side also. So that is not available in case of microprocessor, but most of the pins are programmable, that is capable of having several functions in case of microcontroller. Time taken to complete a process is more in case of microprocessor. So time taken to complete a process is less because of this separate memory map, right? We have discussed in the fifth point. So time taken to complete a process is less in case of microprocessor. That is, it is faster compared to microprocessor. The eighth point, we have it has many instructions to move data between memory and CPU. It has one or two instructions to move data between memory and CPU. More instructions needs more memory to be stored, and increase in the length of instructions, so it is tedious and which is time taking. And the ninth point is it may have one or two bit handling instructions. It may have many bit handling instructions. So bit handling instructions will improve the efficiency and improve the it will provide different options to the user, so you can use any bit addressable register also for his advantage, or to use in the program separately. So more bit handling instructions will result in more speed and more reliability and good program writing skills. So now the topic is list the applications of microcontroller. In today's world, every electronic system will have a separate IC, that is a microcontroller designed for that particular application. So it is used in every electronic device in this today's world. See some of the examples. That is, it is used in household appliances such as microwave, washing machine, coffee machines, refrigerators, digital cameras, alarm clocks, toys, home security systems, remote controllers, exercise machines, air conditioners, and etc. So these are everyday's today's world of electronic device. So each one will have a separate function, they are separate dedicated application, right? So we need to design a separate microcontroller for every different type of electronics. And office and commercial applications such as fax machine, photocopier. Photocopier is nothing but a Xerox machine. We generally call it is in the South India. We generally call it as Xerox machine, but actually we should call it as a photocopier. Scanner or printer machine, intercom, calculators, ATM machines, CCTV cameras, and surveillance systems, weighing scales, elevators, lifts, and telecommunication equipment, that is telephones, phone answering machines, mobile phones, satellites, etc. And in the entertainment and gaming section, we have televisions, VCRs, music players, stereo systems, set-top boxes, PlayStations, video games, musical instrumentations, and etc. In case of automotive industry, it is fuel junction, climate control, airbags, even in airbags, brake control, etc. In industrial automation and manufacturing, motor control systems, data acquisition and supervisory systems, industrial robots, electronic metering, etc. The seventh, electronic measurement instruments, digital multimeters, frequency synthesizers, oscilloscopes, logic analyzer, spectrum analyzer, digital thermometers, tachometers. In today's COVID-19 situations, we are already measuring the infrared thermometer, right? You might have encountered these type of thermometers in any of today's environment. When you go out, the security guard at the outside of the organization or office will measure your temperature, your body temperature, without touching you. You can just point out this pointer, that is the IR thermometer, towards you, and the IR signals will touch your body. Then it will bounce back to the thermometer and will measure the heat signature, that is the temperature of your body, and shows the result, right? So that is also in present scenarios we are using this type of microcontrollers. And further, we have seen these digital multimeters, frequency synthesis, and oscilloscopes in your lab, that is microcontroller lab, or an electronic device and circuits lab, basic electronics lab. Simply electronics lab, we will have such type of equipment. And in the biomedical systems also, ECG recorder, blood cell analyzer, glucose monitor, patient monitoring systems, etc. So So there will be number of applications where we can keep on mentioning this in any industry, in any field. In today's field, these microcontrollers are used in every field. The computer systems, keyboard controllers, even CD drive or hard disk controllers, CRT controllers, DRAM controllers, printer controller, LAN controller, etc. The military weapons and guidance and positioning systems, aerospace industry, and any automatic or semi-automatic device around us usually contain microcontrollers. Now moving on to the next topic, that is state the details of Intel microcontroller family chips. Intel company manufacture these microcontrollers. So there will be different families depending on the number of bits of this processor, that is 8 bit or 16 bit or 32 bit. So we have to see the practical or typical examples of those ICs with the specifications, right? So see first the definition. The special digital system contains a microprocessor, memory, I/O ports, and timer on a single chip is known as a microcontroller. The special digital systems contain a microprocessor. So the definition: the special digital system contains a microprocessor, memory, I/O ports, and timer on a single chip is known as microcontroller. In 1976, Intel introduced 8-bit microcontroller, that is 8048. 8048 IC. It is also known as MCS microcontroller with 48 is the number. The same company continued to drive the evolution of single chip microcontrollers. In the year 1980, Intel introduced microcontroller single chip, that is 51 family, that is the 8051 family. It's higher performance than 8048. So first one is 8048, that is a 8-bit microcontroller. Then it is introduced 8051 family. The below table shows the main features of Intel 8051 family. Please draw this table and write those topics. Compulsory, everyone must draw this table. I will give 2 minutes. Please draw this table. So I hope everyone has draw this table and note down these values. See what is it available in this table. Very first the features. ROM, that is on chip ROM, and chip RAM, timers, number of timers available, that is number of IO pins available, number of serial ports, number of interrupt sources. So these are the critical features of any microcontroller. The chip ROM and chip RAM, timers, IO pins, serial ports, and interrupt sources. Um, you don't need to remember all these 4K bytes, 8K bits, and 0, 128 bits. No need to remember these values for now, but remember these features because these are the required features, minimum features available on any microcontroller. Okay, but see the values. First 8031 we have 0 on chip ROM and 128 bytes of RAM. Timers are of 2, IO pins 32, and serial ports 1 and interrupt sources 6. And 8051 will have 4K, 128, 2, 32, 16. 8052 have 8K and 256, 3, 32, and 1 and 8. So 1983, Intel introduced a 16-bit single-chip microcomputer series called MCS96. In 1983, Intel introduced 16-bit. So MCS 896 family, 8096 family. It contains 16-bit CPU, 8 kilobytes of RAM, 232 bytes of RAM, and timer and counters. So timer will function as same counters also. Parallel IO, parallel IO ports. 10-bit analog to digital converter. This is the extra feature compared to these uh, microcontrollers listed in this table. And high control such as missile guidance and control, complex instrumentation systems, control of sophisticated machines. So these are all the available extra features. So as the years passed from 1978 to 1980 and again 1983, within 6 years or within 5 years, it will be enormous increase in the features of these ICs, and with that the applications also increased tremendously. Now the 8051 is the original member of 8051 family. It is an 8-bit microcontroller designed by Intel in the year 1981. So with this, we have completed some of the introductory part of this first chapter, that is architecture of microcontroller, and we have seen the objectives of the first chapter and definition, basic block diagram of a microcontroller with explanation of each block in this block diagram, and we have already drawn this block diagram. And we have seen the microprocessor unit. We have learned about a lot of new points in this microprocessor unit, and memory unit also there is a classification of primary and secondary memory, which memory is called primary and which memory is called secondary. And we have seen input device, what it will do. It will convert the instructions input data signals into proper binary form suitable for a digital computer. And we have seen the output device, examples of output device also there. And we have seen the most important topic here, microprocessor and microcontroller, difference between the microprocessor and microcontroller. So we may consider the most advanced version of microprocessor is a microcontroller. So different features of microcontroller it will have, and which one is faster and why it is faster, because of separate memory map for both data and coding. And we have seen the real world applications of this microcontroller, number of applications are used. And we have seen the details of the first microcontroller family chips of Intel company, that is in 1976 we have 8-bit microcontroller of 8048, and then again 8051 family, and again in the 1983 we have 8096 family. So like this we have seen the topic. um, so these are all only the introductory and theory part. We have not much learned about this microcontroller till now, only the introductory and basic part only. So most of you have already know these topics, but it is like a revision to your knowledge and revision to this topic also, to this chapter also. So it is only introductory memory part. Tomorrow we will going to see the next topic, that is the features of Intel families, and state the features of 8051. The main part dealing we are dealing in this entire subject, that is microcontroller programming subject of fourth semester of EI 402 subject, the 8051 microcontroller. We will learn about this 8051 in the tomorrow's class. So with this I conclude today's sessions. Please revise these topics at home before attending the next lesson. Okay, thank you very much.